I'll introduce you guys. And
let's do this. Screen share.
We're sort of going to talk to the people that already know. You are.
I know. Yeah.
Clearly didn't give enough extra credit.
Sorry.
And these appear, they hear me scream it all the time up and down the hallway. I'll move myself down there so y'all can just talk. All right. Well, welcome to our third faculty lecture of the year. We'll have another one in April, on April 7th. So mark your calendars for April 7th. That's going to be Hong Yu Lu. She's going to come and speak to us at that lecture. So yeah, I'm delighted to have our two co-presenters here today. I'll tell you a little bit about them, even though you know things about them. So Ian Lundholm is one half of the math department here at Milligan. He's been teaching here for 4.5 years. And he earned a PhD in mathematics with an emphasis in math education from Washington State University. And since being at Milligan has taught at least 12 different math classes. That's pretty impressive, right? Including developmental mathematics, math for elementary teachers, calculus, linear algebra, and most recently robotics. Ian would like to make it clear that while he had no prior experience working with robots, he thinks they're really neat, as do I, and has been learning a great deal researching and working with our students. So Dr. Teresa Carter is a 16-year veteran in the computer science department at Milligan. She's seen massive changes in technology, I bet, in the field, and has integrated those into the curriculum that serves our students. As the development of artificial intelligence is now an integral part of systems and coding, introducing robotics to the campus is especially rewarding with such a, I'm getting way off topic here, especially with such a successful engineering department. So we produced a place where STEM programs could interact. It's been an honor for Teresa to be part of this exciting addition to Milligan's offerings in robotics. So we are happy to have her. So welcome these speakers as they talk about robotics and critical thinking. Will it work?
Maybe right.
Oh, there it is. Okay.
All right, a little bit for the agenda for tonight. We want to talk about why we're studying robotics. We want to showcase what our students are doing, and maybe they'll help us out doing that. And then looking into the future of what can happen. But yeah, under what we're going to talk about now, why we're studying robotics. Robotics are going to be integral to the future of work. It is a great opportunity for cross-disciplinary collaboration here on campus. And it's an opportunity for critical thinking. It's great. It's a valuable piece of the total package of a Christian liberal arts education. Mind if we start off with a video? It's pretty short. And there's not much audio to be had here, but just some eye candy of different robots that are currently in service or soon to be in service.
The cows are not robots.
3D printing a house here. Yeah. It's pretty spiky. Not all the time. This- Oh, well, all right, yeah, that's great. It didn't need that last part. We didn't need that last part.
Will our children be ready? It's like the.
Hey, that's why we're here.
Open doors.
I know that was a little bit too cryptic and, you know, anyways. The hype is real. There's
real.
yes, there is quite a bit of hype. Have you heard that, you know, robots are gonna take our jobs? That kind of
Robots are not going to
sentiment.
take your jobs.
They're not gonna take our jobs necessarily, but I think that they will be integral in
They
a
will.
lot of different areas.
They will.
in the
And
coming decades.
that's always a big topic. It always comes up in my classrooms, always. Well, how do you feel about, you know, all these jobs that are going to be gone? And I said, name me one. And they can't, because it's not going to be that way. And the word here that we have used loosely now for a while, and nobody pays any attention to it, is called retool. And you have to retool your skill set. You have everything it takes to integrate with what's coming up. But you need to have a mindset that that's what you're going to do. You need to retool. And so this is, you know, it's not going to lessen our jobs. It's actually going to create more jobs, because everything that you think has a downturn to it, there's going to be an upturn to it. And you simply have to look for those opportunities, develop them, and get the education that you need. And, you know, it's like, well, I've already got my bachelor's degree. That's fine. That's wonderful. I really applaud you. Now go do your master's, because it's never going to end. It's just never going to end. You can't do that. You're not going to live in this world and not pursue education every time you turn around, because that's what you need to do. You really need to do that. And one of the things you had up, that's okay. You don't have to do it. But I come into contact with in October. And so they wanted me to have a needle biopsy, and I thought, oh, wow, this is going to be fun. And so I went in for this needle biopsy, and guess what it was? It was a robot. And they put me in a CT machine, found where everything was that they wanted. They pointed this thing at my back right here, and they gave me just enough sedative that I wasn't moving at all. I could roll my eyes independently, I think. And I could feel what was going on. I knew what was going on, and shot me in the back. This robot shot me in the back 3 times. You could feel it, you knew it, but it was totally pinpoint. They couldn't do that any other way. I would have not been able to have had that detailed diagnostic without it. And one thing we were just standing here talking about, we saved more lives through COVID. You have no idea how many deaths we would have had if we had not had artificial intelligence. Because what we did with artificial intelligence was we came in and image recognition, which is one of our challenges here with robotics in our Mate Rove, is a huge deal with artificial intelligence. It loves it. You can write those on the fly. No joke. They're easy to write, to integrate into the components you already have. And what happened was we took this artificial intelligence and we moved it into the radiology, and it took an ordinary X-ray, and you saw on the screen how it identified pneumonias. And so we saved more lives with COVID because we could identify them quicker. It was a simple x-ray. It wasn't a CT scan. You didn't have to wait for somebody to come and read that. Okay, it was there, it was done, it was in front of you. So we saved a lot of lives that way. So you think, well, okay, we're talking about robotics. Why are you talking about artificial intelligence? Because one runs the other. There's no way around that. Everything is going to be influenced by artificial intelligence, and it is most going to influence robotics. So this is a whole open field out for you. I mean, there's going to be plenty of places to retool. You just got to want to do that. So.
Great. And the second reason we're talking about robotics today, doing robotics here at Milligan, is because it represents a really great opportunity for us to collaborate across different programs. We got mechanical engineering, electrical engineering, computer science, and mathematics is there just because I'm here.
Yes.
And Kayla's here too. But it's awesome to be able to collaborate and truly be part of a team where you need each other.
Yeah.
No one person on the team has all the expertise to make as good a robot as we could together.
We're smarter
It's so
all
cool.
together
Yeah.
than we are by ourselves.
And as part of this Make ROV competition, there are also elements of business leadership.
Yeah.
Henry is taking a crash course on business leadership right now as our company CEO.
Henry, you are a great CEO.
Yeah.
Your emails just light my day. I love it. So.
But business leadership, we'll need to make marketing displays. We are currently getting involving a couple students from our graphic design program to design us a new logo for the team, which is great. It's really cool to be part of something where everybody gets to come together.
And I have never had a math student come into my computer science classes that didn't stop me at the end of a certain number of classes and say, I had no idea I could use my mathematics this way. They always. So anything that we can cross discipline, anything, that we can involve everybody else in. Your field is absolutely open so much to this for nursing homes, this type of thing, anything that needs psychology, the psychology of help. It's amazing what's happening out there. So that we can use this as a cross discipline. The critical thinking, we're going to talk about that in just a few minutes, but the critical thinking aspect of this is amazing. Absolutely, totally amazing. That's what I see happen to students.
You mind if so that reminded me, this cross-disciplinary thing, I was actually able to use something that I have been learning about robotics in my linear algebra class. You mind if I bore you for a couple seconds with some math?
Heck yeah.
All right. It sounds like everybody wants to hear about that, so we better do it right now.
Do it right now.
Come on. Oh, I put a link there. Oh, well.
Go ahead.
We can-
wing it. You can wing it.
I mean, I can come back.
Okay.
Well, I know where to find it. Sorry.
You're okay.
I had it open.
You're-
All right, here we're good. I had it linked. Here we go. This is a master's thesis from Chujo Wu, who's bachelor's in engineering, who had a bachelor's in engineering, but working at Flinders University under this person. So I am shamelessly, just showing you stuff from somebody's master's thesis here. But it is super cool because I was able to talk about inverse matrices looking at this. So what this thesis is, it's all about thruster configurations and thinking about how thrusters on an ROV, which is a remotely operated vehicle that, is a robot underwater. It's what we're building. It uses, this one has 8 thrusters on it. Here we go. And when you're controlling a vehicle like this, there are 6 different directions that you could head in, and we call them degrees of freedom. But there is surge, going forward and backward, sway, left and right, heave, up and down, and then there's the rotational axes of pitch and yaw and roll. And so one of the cool things that I was able to bring into my linear algebra class is first, show off these wonderful rotation matrices, right? Those are cool. But getting into thruster configurations down here, one of the things that you can do is, all right, so this specific ROV has 8 thrusters. 4 of them are in a vectored configuration on the underside of the vehicle down here. So they are at like 45-degree angles. And then 4 of them are oriented vertically to help the robot go up and down. But yeah, that ends up, you can encode that in a 6x8 matrix where, yeah, you have all of the surge, sway, heave, and roll and pitch and yaw values for each one of the thrusters. And this matrix and its inverse matrix help you encode and go back and forth. What's the word for that? Go back and forth between the input signals that you need to put on into the thrusters saying, hey, thruster number 1, you need to start. And thruster number 3, you need to go backwards. So those input signals that you need to send to the thrusters and the 6-dimensional vector that tells you exactly how you'll be going. So will you be going forward and rolling at the same time, all that good stuff. It was a really cool opportunity to bring that into the classroom. Yeah. And it is what we were talking about. Yeah. And it's something that I never would have had not working with robotics. Yeah. Yeah.
You would have overlooked it.
Yeah. So it's a super cool thing. We all gain when we're working with each other.
Always.
Yeah.
Always. So we are affiliated with what is called MATE Rove, and this is a marine advanced technology for a remote operated vehicle. What MATE does, and it's a great company, it's located out on the West Coast, and they've covered the United States, or the world actually, with this idea of taking high schools, colleges, universities, and some middle school. We have middle school interaction here to actually get students into actually learning how to build prototypes. So we get accused a lot of playing with toys. And so, okay, so I'll take that. But what is a toy? It's nothing but a prototype. And that's, when you think about that, of what we are here doing and what MATE has put in there. The thing with MATE is that they hunted something that we needed a sustainable future for. Mm-hmm. And so all of the challenges that they issue for the teams every year have to do with a critical issue on the planet, and that we need to correct. And so we need to correct it with as small an imprint that we can possibly make. So we choose smaller things to do what a human or a group of humans are going to trample, a very delicate coral reef, where this can go in, where our rows can go in and literally do what we need. You can fine tune those to the point where they literally can pick off just that one little bitty piece that you need to make that discovery of how we can literally make our planet more sustainable. So this is, it's a true and current problem that you're working on. It's not just something to build a robot and do this one thing. It actually goes all your, everything that happens in the competitions and how it worked and how long it took us to do it and what we had to do for that. Did we back up? And that's let's see, yeah. We have one, where is it? Here. We have this, we have this one challenge. We'll back up here in just a minute. But when we think about that as a critical thinking issue, so, the definition out there, the most one, used is the objective analysis of evaluation of an issue in order to form a judgment. So in robotics, we refine that definition just slightly, but that slight adjustment means, we can solve world problems. And that is because it's the art of producing a solution to a critical ongoing problem using limited materials or tools, because you're not given a whole lot. You can testify to that already. You're not given a whole lot. And so one of the things that I really wanted to tell you about is, how thinking outside the box and those challenges that are presented. My first time with Rove was just out of the blue. And I got a call and we need somebody that knows how to program Python. Can you come and judge the image recognition? We have a few teams that attempted it because that's a big deal. That's tough programming. That's a tough problem that you make something mechanical, be able to identify certain images on the floor of the ocean. And so I said, sure, I'm up for that. That'd be fun. So once I had judged all of the teams that had even tried that, attempted that, which was just amazing. They come and said, hey, we've lost one of our engineering judges. Will you come and judge engineering? Oh my goodness, did I fall in love? I have never in my life seen such ingenuity. And this was at the Worlds. I had done regionals, qualified me for Worlds. And these students, these young people, high school students, I traveled halfway around the world, dragging this little machine with them, and what they had done was just incredible. We had teams that, I would sit and listen to them. I ask them questions. How did you do that? How did you get past that? What did you do that was different from everybody else that you solved this problem? What did you do? And they could tell me exactly what they did. So the team from Hong Kong, the coach, I love to talk to him. He's a hoot. Let me tell you, he and I, we could have fun together. And he brought the team in and they let him come in and sit down. Usually they won't let the coaches in the room with the team. The team has to do it all by themselves. And so he came in and they let him sit down with him just because of language barrier, that kind of thing, just to make sure his English was impeccable. So he and I had no problem. And he leaned over, as a judge, he really shouldn't have, but, we talk back and forth, as far, just so we all are on the same page of what's going on. This team was just polished. They were polished, totally polished. And it was evident that they had a little more money than Milligan does. And, they had bought a lot of stuff that we have to make or deal with, recycle, reuse, whatever. And that didn't hurt us. In fact, I think that makes us better. And I don't want you to have everything. I want you to struggle. I really do. Because, that's what creates critical thinking. Because you're going to think about it. Because hopefully you don't want to disappoint me. And, that's a motivation there. But if that's what gets you to think critically, then that's what we're going to do. And I think all of you know that I'm right there behind you every step of the way anyway. So, he leaned over to me and he said, I said, well, they're doing really great. And he said, yeah, they are, to have never had the machine in water.
Wow.
And I said, are you kidding me? He said, we didn't have access or time. And he said, we brought the machine without it ever having been tested at any kind of depth. They didn't even know if it was waterproof. They were just joking. They just pulled that off. And it was wet. It's why I asked him. I said, how come it's wet? He said, we got 3 minutes worth of pool time and dropped it in and left it there for like 2 minutes just to see if anything was if it was going to totally flood, then, they were going to pull it right fast and tell us that we need judging later. But it held up, brought it in. Water was running everywhere. And, I said, maybe I ought to go out there and put a liner in the bed of my truck, fill it full of water and put a sign up that says, test here. He said, I'd go do that in a heartbeat, because this was a great team. One of the greatest teams that comes in there is the Egyptian team. They had a female programmer on their team that literally was phenomenal. She had a 3-second delay she wanted rid of. She sat there and she kept programming until she got rid of that 3-second delay so she could triangulate the cameras, because she wanted what she wanted. She didn't want a downward camera. What she wanted was for the outside cameras to triangulate and give her a down view of the image on the bottom of the floor. And she kept up until she got that 3-second delay gone. She was phenomenal. I put her in for a special award. I have never seen innovation like that, ever. I was totally blown away. And I said, we've got to have this. We've got to have this. This encouragement, this place where you can think free, where you can do things that if they fail, big deal, that we learn something. That's it. And we put it back together and we go again. But the two teams that literally had no money, had no way to get parts into their countries, and that is Turkey and Mexico. They were the most ragtag two little groups I ever saw in my life. How they got there, how they got to the US, I don't even know. They didn't speak English. They'd have one on the team. They brought the one that could speak English. Honestly, they held their things together with duct tape. I swear I saw duct tape. And these young men, they had no women, I'm sorry. They had no women on these two teams. I don't know whether that is a cultural thing. I meant to look into that to see. So we have at least passed that barrier, hopefully, for good. But they literally made some of that stuff by hand, literally made some of the parts that they needed. So I gave them points just because of ingenuity. I mean, it worked. Their rows worked. And you just, when you witness that, you just think, what we waste over here? I mean, what the mental energy we waste over here? It's unreal. These guys had worked for months making it work. It meant something to them. And the one that spoke English told me from the Mexican team, I said, is this your entire team? No, it was only the ones that we could pick and pay for over here. And I said, so you have a good sponsor. He says, Shell Corporation sponsors us. And they, and he said, can I tell you something? And I said, sure. He said, they've already bought our prototype to run the bottoms of their big vats. They were so proud of that. And it was put together with duct tape. So, this is an experience that you won't even realize the value you have gotten out of all the long hours and the frustration and it not working and it not working and it not working, and all of a sudden it works.
We'll get there.
Yeah.
We'll get
You
there
see,
soon.
there you go. That's what this is about. It's why I'm so excited about it, and will always be excited about it. So, you want to talk about building a team?
Oh, sure. Well, Teresa started things. She recruited me. And then, yeah, I mean, recruiting students, thankfully we have a great talent pool here at Milligan. And it has been awesome to work with students and form relationships. And yeah, I mean, I don't know that we have any secret sauce to how we recruit necessarily, but talk about it in our classes and
Yeah.
talk about how cool of an opportunity it is.
I think that's one of the things I've always said since I've been here, that's just the magic of Milligan. Honestly, I mean, that's just the way I feel. If I take you all into the high schools, into the middle schools, I know that without even prompting you whatsoever, that you're going to say the right thing. You're going to encourage those students. You're going to show them what it's like. You're going to show them the better side of what it can be, what life can be. Because there's a whole lot of students out there, kids in school, that have the awfulest life you ever thought about, that you don't know anything about. And they're not going to tell you, but you could say one thing that would change their whole entire life just by this. So that is the magic of Milligan. That's why I love to take students out into the community, because I know that is the one place I can always count on you to be exactly who you are. And I'm always proud of you, always. So,
And mentioning going out into the community, Megan has been a part of Vex Robotics in the past and found out that there is a competition happening, I think on the 19th of February, out in Bluff City.
Yeah.
And we are sending a small crew of students to go and volunteer as judges and stuff. So we're going to meet high school students, middle school students, and hopefully, serve them there and learn a little bit about that competition, and it'll be great.
and they may look at you like,
No.
but you have no idea what's soaking in here. Because
Yeah.
I mean, they don't let you know, but you'll find out, because they'll show up on campus one day and say, he told me, and I want to be like that.
Mm.
It's the biggest compliment ever. One of the biggest compliments a student gave me one time was, you left me better off than you found me.
Oh.
Absolutely. That was the most wonderful thing any student ever said to me. So, yeah. So that's what you need to do. Leave people better off than you found them.
All right, so a little bit of specifics, a little bit of team history right here.
Yep.
This little picture is us, weighing in our robot, getting it checked out by the safety officials there at MAPE. This past year, the World Championship was at ETSU.
Yeah.
It was in our own backyard. It was
Yeah.
amazing to be able
We
to
have
do
been
that
so
for
lucky.
our first in-person competition.
And that was the saddest day of my life.
This year, it's going to be in Long Beach, California.
Yeah.
So,
That I couldn't get to that one just broke my heart.
oh,
We
yeah.
had worked so hard, but I was so sick that day. I could not do it. But I was so proud of you. And you all sent me pictures, and it kept me going that whole day. So,
Yep. Yeah. So I also have this video queued up real quick
yay.
so that we
That's
could take a
awesome.
look at what the robots in the pool actually look like. There's some commentary here, but maybe I can commentate. All right, we see 4 ROVs in the water. Do you know which one is ours? Look for the tennis balls on the corners. We're this one right
Yeah,
here.
that
So this was us last
The one dancing.
August. And this is actually a video of the bonus mission at the end. I probably could have picked a video where you see all of the different tasks they have as complete underwater. But I thought this one at least is, to me,
Yeah.
the most dramatic.
Yeah.
There is some epic excitement, and also at the end, a little bit of heartbreak. But we have a working ROV at this point.
That actually is doing something correct.
That's doing something correct. You know, we had some students work on that robotic arm at the front. And, you know, other students think about the flotation of the robot so that it is neutrally buoyant and able to maneuver, you know, at depth.
And I know that was frustrating. I know that was one of the most frustrating parts that you all had to work on. And I know that, but in competition, I actually saw one that had a kitchen tong. Just so they knew they were supposed to have a micro arm out on the front, but there was that kitchen tong, and I looked at that. Okay, comic relief, and that was pretty ingenious to think about that, but yeah.
So yeah, we're struggling with the float here at the moment, but yeah, this bonus mission is you grab a float off of the bottom, bring it up, reattach it to your robot, and then come back down and attach it to this banner that is supposed to come up. But yeah, it was super fun. This mission is supposed to be cooperative. There we go. That's us.
See?
Bringing that up to the surface. I was so proud of our students.
Me too.
Yeah,
There's
so
no way
proud.
not to be.
Here, this is just some above the thing. Yeah, it was great. Here, let's get to
So this
the-
is what command,
another
the
exciting
control
part.
and command.
Oh, yeah,
And this is
sorry.
why it's so imperative that
About that.
we really work on great and new designs for the tether lines and that kind of thing. So for those of you, you know, may not know what happens out here, how we, you know, and we've got a really good design. We handle our power and that kind of thing differently, and our communication. So we have a smaller tether line, and that's great. Those kind of innovative things, when we show the judges, it's really impressive. So I think Ian has come up with an even smoother design for the
Ah.
chassis. I think we ought to try.
No. I mean, the students are taking over. So
Okay, there you go.
I've done some prototyping work earlier on just to get the creative juices flowing. But our students, and I'll show you some of the stuff that they're working on
So you need to.
right now.
Yeah.
They are,
Those are.
they're off and
That's
running.
what they want to see.
They're
And-
doing great.
Yeah.
Our electrical team is doing a great job thinking about
Yeah.
organizing everything that we're doing.
And that's
It's-
where.
Yeah.
That's where I am very competitive. To say the least, I'm very competitive. And so that kind of thing, new designs, we can take in there, you know, so, okay, I'm a show off. So, you know, that's what we need to do, because we need to show that off. Fantastic.
Yeah, so that's a little glimpse into what a competition actually looks like. You've got teams of students running through obstacles. This year, we have been tasked on working with a variety of challenges with sustainable energy, mainly focusing on offshore wind farms. Also blue carbon and offshore aquaculture, so raising fish for food. And finally, climate change. And the focus for this year is Antarctica,
Yep.
because there's an actual real life expedition going on this year called Endurance 22, where they're going to search for, well, the wreckage of the Endurance is what it was called, right?
Right.
Shackleton?
Chuckleton.
Yeah. So that's going to be, so that's super cool. The tasks that we are assigned to attempt to complete, they're based on real world challenges. And we've already talked about that. That's good.
So you want to let him to come?
Oh,
Ready? No, you're going to talk about fusion. Do that one. Tell him.
so
Yeah.
yeah, we can do that anytime. But yeah, just coordinating a team. These are some of the services that we use.
Mhm.
And it is, I don't know, it has been a blessing to work with these folks, and the coordination, the real life problem solving and cooperation that needs to happen as part of a robotics team is great. So we're learning, industry standard tools like GitHub and Fusion 360. We are communicating in a myriad of ways using calendars and file sharing and all that good stuff. But yeah, showing this, I wanted to show off some of the stuff our students have been making lately that is online. And I don't know, there's a whole bunch of links that I can just click here. But this is a design within Fusion 360, which is mainly utilized by our mechanical engineering team and our electrical engineering team. One of our students, Darren Pickelheimer, is working on a frame design that last week we actually went up to the engineering labs and 3D printed one of these parts. Super cool. But yeah, our plan this year, we've got a new aluminum enclosure for our electronics. We've got this, PVC frame coming together. And yeah, I mean, we're hard at work. We're still in the design and prototyping phase, but we hope to be in the water by March. In March, yeah. So there's.
And we want to thank the swim coach and swim team. I mean,
that's
they move over and let us have space and time. So we're very grateful for that. And I would like to really put in a word for our security on campus. These guys think you all on the moon. They really do. And that they go to bat behind your back that you don't even know about. These guys go to bat for you. They go and tell if they're asked about what was going on campus, they very quickly defend you guys. It's no. These guys were working. We watched them. They may have been in the lab at 3 a.m, but they were working and they really go to bat for you. So, be nice to them because they have certainly been nice to us. So we try to make sure we think who's really out there, helping us out. And I've got a challenge for you, probably in less than 2 weeks. But I've ordered us a new 3D printer.
That's right.
So we can set that up in the lab and have it going. The only thing, you know how I am, Dr. Carter up here, she teases me. I decided I needed microprocessors in the lab. And so we were going to order some, and I had ordered one and I showed her what we could do with it, what we were going to do, what the vision was. And she said, sure, go ahead. So I ordered them. She came in and looked and I said, well, see our new microprocessors that we've got, Raspberry Pis and Arduinos. And we had a little small stack of them there. And she said, but they don't have any instructions. I said, we don't need no stinking instructions. And so she's teased me about that ever since. So guess what doesn't have instructions? You got it. Because we're going to put it together. Because if we put it together, then we're going to know how it works. Okay. So I don't want another one sitting there that I cannot get into it and figure out what's wrong with it. So this is what we're going to do. Okay, so yeah, that's my ideal of fun. No instructions. Don't have to. So we've got that coming up.
I suppose I'm the yin to that yang because I love watching. I love using instructions to get it right.
Instructions. I don't love instructions. Forget the instructions.
Okay, no, that's good. This is an electrical diagram that our students have made on Fusion 362. Wow.
That looks
There's
good.
Our Raspberry Pi, all the GPIO pins that need to connect to our different ESCs, electronic speed controllers, that will then in turn connect to our thrusters. This is a schematic of that. So yeah, we've been having electrical engineers, mechanical engineers. Page not found. Let me sign in. Oh, come on. There we go. All right, I just needed to sign in to GitHub. This is for all of the coders out there, but this is what code looks like. This is Python code. So yeah. And there's a lot of work that needs to be done there too.
This is what we're showing you.
But yeah, that's all student generated stuff.
Yeah.
Super cool.
Dedicated student power. So fantastic.
Cool.
Yeah. So one of the biggest things that we need to do, we need to keep in the air, going in the air, our balls that we juggle, is not just working on, just the road itself. We want to make sure that we refine what we do, that, all of the abilities for thinking out of the box. And I really like that term of thinking out of the box, because that's what we do the whole entire time. And developing solutions for critical applications. How do we apply this? You may come up with something that has nothing to do, will not help the road at all, but it may help something else that is essential out there. So, you know, don't throw away an idea. You know, that's how you really create stuff. And then working as a team, I think that's one of the biggest dynamics that we have that going for us. Community outreach is a must. You have to give back. And everything that you've learned here, we want you to take it back. And, you know, I'm constantly looking for places where we can do that and get out there and show other people, other students, other young people, especially, what they can dream about, what they can think about. And yes, I know COVID has been absolutely ravenous when it comes to that kind of opportunity, but we're going to be okay, and we're going to get through that, and we're going to figure out how, because we've got to figure out how to learn that. And that's just another critical place, you know, that we need to think out there. So any questions? Because we've talked pretty long and hard.
Yeah.
And you can tell we're excited.
Is this all extracurricular, or is this blended, or are students getting academic credit?
So up to this point, these students have donated their time. This is strictly that they saw the value in it. Slowly, we are breaking that barrier, because it takes time to do those kind of things. And we have to be patient, and we have to stay steadfast. And so they have never, ever saw that they're not in it for what they get, that they're going to get something. They simply think it's important, and we think it's important, and we think they're important. And as we go forward, we will, you know, we'll break that barrier too. Not that it's a barrier, it's just something that has to be done in a certain order through certain, you know, that's policy. So we're very much into that. But
And as a quick disclaimer, there are 5 students in Math 325 Robotics, which Carolyn helped us set up.
Yeah.
And 2 of those students are here right now.
Yeah.
So they are getting.
They thought it was worthwhile.
3 credit math class.
Yeah. Yes,
For
we
this
did get that put in,
semester, yeah.
that they actually, if you needed an elective or whatever those credit hours you need, we did get those, have a place where they could actually do that.
That could be under $4.99 too.
Yeah. So
I mean, that's an easy way to give academic credit. If you guys want to do that, or think about that.
we chose the easiest thing to meet. Mate Rove works it on its own time schedule. So we have to really work at making the semester fit. So you all start at least 2 weeks ahead, you know, and so, yeah, we kind of have to work with that. So it fit closest to what we needed for Mate Rove.
I have a question.
Yeah.
After the moment of inspiration, we decided to do this at Milligan. How did you pitch it to Dr. Long?
How did I pick?
Yeah.
Hey, you stood too long in my office.
That's true.
I just went. I had a coach, I had a co-coach, and as life always will hand you too much at times, and I knew that it was going to be way too much for him, and so Ian and I had been talking about a lot of stuff, and he was standing there, and I said, "How would you like to be my co-coach for the robotics team?" And you know, he never hesitated, not one second. It was, yeah, that
She
sounds like fun.
invited me up to a workshop. At that point,
Yeah.
Streamworks was up in Kingsport.
Yeah.
And there was a day workshop for local educators in the area that we went up and we made a little pufferfish kit robot, and that's actually still in the CS lab.
So we went to build,
But yeah,
and
I learned how to solder.
Yeah.
For the first time. That was cool.
And I just never shut up about how wonderful it was, just getting my feet wet with being a judge. And we have the same energy level and the same drive and desire and the same vision. And so for the students here at Milligan, and it just clicked. So we made a really good team. I haven't regretted that. Like I said.
Yet.
If any of you ever get the chance to work with Ian, do so. He's phenomenal.
Thank you. I'm gonna show us the robot, yeah.
Yes. We have a guest.
His name is RoboBuff, formerly known as Robot Dog.
Yeah,
Henry, and was it Henry and Dr. Longholm? Did you guys work on 3D
Yes.
printing that?
Look, can you see the buffalo?
Yeah.
the buffalo face, but
It
yes.
used to have just like 2 little pointy ears, but now they 3D printed a little face for it, a little face plate. Yeah. And that's we worked on this for the first couple of weeks before we started getting into Mate.
Right,
It was kind of like and part of last semester.
yes.
It's kind of like a dive in before we actually got to work.
Yes, we were hoping that RoboBuff would be able to help us, with community outreach, as students come for preview days, as we go to different competitions, you can come along and be a little mascot. In a more practical sense, one of the things that we need to do this semester is utilize a Raspberry Pi and, do image recognition tasks and learn how to navigate a pool. We're not gonna have the opportunity to be in the pool all the time. So having this where we don't have to be in the water, but we could theoretically play around with Python code and learn it. One of the things that we want to learn or teach you how to do is just to follow. We've got a little red ball that we'll want it to,
Part of the image recognition
Yeah.
idea.
But yeah, it's RoboBuff. Right now, it is not
Calibrated properly.
currently calibrated properly, but he's hobbling along.
I don't know, you look pretty good.
It's not quite Boston Dynamics
No.
spot yet,
It's okay.
but it has colorful lights. Yeah, right?
Make
It
it
could be a
better.
Christmas tree. I would like that.
We do want to 3D print a hump for it soon.
Even make it bellow.
All right.
The mighty bison.
If anybody wants to try, you're welcome to.
It's a dream to be able,
It can.
that we could
Yeah,
actually
press on that
have
little
a pool
camera
and
icon.
actually invite some high school teams in and show off, really, to show off what can happen, share the pool with them, full time, let them test. Because just putting it in water, you find out the hard way. Just putting it in water does not mean it's waterproof. You need to drop it till about 12 feet and let it sit there for a while. Because, you've got to test under different degrees of pressure and circumstance and that kind of thing. And the divers that we have that set up our props and stuff whenever we compete, those are the coolest guys ever. They just stay in the water, and one of them laid on the bottom and slept because they'd been searching for a body in North Carolina, and he had come up to do the robotics competition of setting it up, and he was just worn out. And so I watched him, and his wife was standing there. She says, "Yeah, he's asleep. He does that all the time. He's sound asleep, just so he was fine." So they're really, so you get a taste of a whole lot of stuff when you compete that you don't otherwise, and it rounds you out to
it's a really great experience, especially internationals. I feel like the internationals are almost as good as a out-of-country experience. I mean, it really is. So you get that same, because you're together for, sometimes 4 days, and you get to know. I thought the Emirate Arabs were going to take me home with them. They would follow me around like a little troop. Can we come over and go to school at your school? And I'm going, I have no idea about that, but we will try. So the teams, if you're friendly, they get attached. They'll get attached. So it's just a different experience. So, and I hear from a couple of them every once in a while, waiting, can't wait. Will you have your team there? Yes, the team will be there for me. So. Okay.
Maybe you all appreciate you coming.
Really appreciate all of you coming too.
What kind of programs is it?
Anything else that you guys wanted,
Yeah.
Want to
anything
tell
you guys
everybody
Want to say
while
anything
you're
that you feel is important? And I saw that look.
if not, that's okay. If not, I just wanted to make sure I didn't forget anything super important.
Well, you all are a pleasure to work with. You really
Definitely.
are. You are a pleasure.
We will be in the water before March.
Before March,
That's mine.
Ooh,
That's
cool.
our- we want to be in dumps. We only have to be
Fantastic.
right.
we are off to a good start this
Manifested.
year, and it's mainly due to this,
Yeah.
the students.
Yeah,
We're off to a
they
really
are-
good start.
They are totally dedicated. I mean, they really are.
For one of
And we graduate and that, and a new group comes in and they're totally dedicated. And the ones that move out, they come back to give us advice and, so they become almost a brotherhood, sisterhood, and that's good. That's a wonderful thing. So, yeah. There we are. So that's what we're doing on third floor where nobody's looking. And we sneak over into the electrical and mechanical
Yeah,
labs.
we go in the
for
maker
engineers.
space this month, I guess.
Yeah.
If we can
Yeah.
get in the water, yeah.
We're gonna go into the water. I like to be over there.
Cool.
Thank you all for sharing.
Thank you all.
Thank you.
I've got a couple of t-shirts for Teresa and Ian, but you know what? I think I ought to give some to the whole team. So if
Oh,
everyone's giving their
wow.
size, I'll get that way you
Look
don't
at
have like a team of shirts, so.
No.
I don't have. You'll have just send me your size and I'll send them over to Ian, their research buffs, so that you can have matching
nice.
shirts.
Thank
You
you.
can have a matching shirt for when you're big.
Thank you.
So thank you all for
That's
coming.
awesome.
So,
Thank you.
Yeah,
Thank you.
just email me sizes and I'll get y'all
Okay.
those. So,
Okay.
Yeah. Well,
Sweet. All right.
We'll have a good
does
time.
somebody have that?
All right.
Y'all got it?
Thank you so much.
In there.
I gotta turn
Okay.
off.